In this lecture, we will discuss about dynamic scheduling. So before that, we should know what is static scheduling. So the pipeline concept is the static scheduling. So in that, we can say that our when we are executing the instruction, it will follow the in order issue, in order execute, in order completion. So because of that, what is the limitation in this? If two instructions contain stalls because of the dependency, because of row, those instructions which are present lateral, they are also going through the what stalls. So to avoid, to minimize that thing, we are using dynamic scheduling. So in dynamic scheduling, we are doing what? In order issue. Okay, one by one instruction will be entered into the scope, into the approach. Then out of order execution, out of order completion. So because of that out of order completion, the another two hazards will occur here. That is WAR hazard, WAW hazard. That means in dynamic scheduling, we will check these three hazards, whether these are present in the instruction or not. But in static scheduling, only we are checking the whether raw is there or not. Because automatically WR, WW are omitted in the static scheduling. Okay. Now, what are the approaches for the dynamic scheduling? So there is two approaches. So one is scoreboard. Next one is the chromosome. Okay. So now we'll discuss what is scoreboard approach. In this scoreboard, we'll see these three tables. One is instruction status table, functional unit status table, register file status table. In instruction status table, there is four stages. What are the stages? Issue, read operand, execute, and write back. So when an instruction can be issued or not. Okay, so for that, what's the condition? If there is no structural hazard, if there is no WAW hazard, if there is two hazards, then any one of the hazard, then we cannot do the issue. If there is these two are absent, then we can issue an instruction. Then when one instruction enter into the read operand stage, if there is no RAW hazard. Okay. Now for the execute, there is no condition. So if one instruction enters the read operand, then that means they can enter into the execute. After that, next clock cycle. In write back, whether one instruction write into the register or not. So it will check on the WAR hazard. Okay, whether the instruction can be write into the register or not. So that is your checking will be, if there is WAR hazard, then we cannot go to the write back stages. So we will wait for that. Okay. Now, so these things we will understand through the example. Now comes to the functional unit status table. In this functional unit status table, so what is functional unit? So there is four functional units are present in the scoreboard. One is integer, add, multiply, and division. Okay. So each functional unit has the 9 fields. Okay. So now you see whether the functional unit busy or not. So here the answer will be yes or no. So what operation it will do? For the integer, it can be do load or it can be do store. So what is the destination register? F5, Fj, Fk. Destination register, source register 1, source register 2. Now comes to this Qj and Qk and Rj and Rk. So Rj and Rk are the flags who what it will say whether this Fj or Fk are available or not. So Rj is corresponding to Fj. Rj is corresponding to Fj. So whether this Fj is available or not. Okay. That means this here the answer is also yes or no. Same for the Rk. Whether Fk is available or not. So here yes or no. Okay. If it is available, then okay. If it is not available, then that will be notified by the user. Which functional unit will provide that value? Okay. Which functional unit will provide that Fj? Say for the Qk, if Rk is not available, means Fk is not available, then Rk corresponding will be no. So if it is no, then you will write which functional unit will provide that Fk. Okay, so we'll understand through the example. Okay, so you can clearly understand through the example only. Now, what are the functional units are there in scoreboard? Integer, add, multiply, division. So in the integer functional unit, we can do load and store operation. In add functional unit, we can do add or subtract. In multiply functional unit, only can do the multiply. In division functional unit, do the division operation. Now, we'll see how many clock cycle takes for each instruction. If it is load and store instruction, it will take one clock cycle for the education stage. Okay, it is for the education stage. If it is add or subtract instruction, it will take 2 clock cycle. If it is multiply instruction, it will take 10 clock cycle. If it is division instruction, it will take 40 clock cycle. Okay. Now, come to the third type of status table, that is register file status table. So here you will write which functional unit will write on that register. Okay. So now we will discuss one example.